Okay, in this video I'm going to show you how to do step 1 and step 2 on the Puzzle Cube design project. Step 1 is pretty simple. On step 1, all you have to do is read through this design brief, the puzzle design challenge brief. Make sure you put your name here as the designer. Read through the whole thing. If you have questions, make sure you ask. But you need to be looking at the criteria. Right, the puzzle must be fabricated from 27 3/4-inch hardwood cubes. The puzzle system must contain exactly 5 puzzle pieces. Each individual puzzle piece must consist of at least 3, but no more than 6 hardwood cubes that are permanently attached to each other. Basically, this is something after you have built it. Notice like this one, there's 1, 2, 3, 4, 5, 6. So this one would have 6 in it. So it can have as little as 3 or as many as 6. All right, no 2 puzzle pieces can be the same. The 5 puzzle pieces must assemble to form a 2 1/4-inch cube. And at least 4 out of 5 puzzle pieces must be interlocking. And what I mean by that is, I don't think any of mine are not interlocking, but a non-interlocking would be something that is on one plane. Okay, so something like this would be not interlocking because there's not that third dimension that sticks out of it. Something like this is interlocking because we've got one plane here, right, all of these cubes, and then we've got one sticking up here. So if I didn't have this one and it was just this U, it would not be interlocking, but because I've added this extra depth, that's when it becomes interlocking, and that's what I mean by interlocking. Okay, so you just need to print this off with your name on it and paste it into your engineering notebook for step 1. Now step 2, it says generate concepts. For this one, you're going to brainstorm and sketch on isometric grid paper possible puzzle pieces combinations for your cube. You can have pieces that contain 3 to 6 wood cubes, which we had just talked about. Be sure to have 4 sketches for puzzle pieces with 4 cubes, 5 sketches for 5 cubes, and 6 sketches for 6 cubes. And let me explain what that means. If I was to look at, say, 3, I know you don't have to sketch those, but we're going to just kind of look at that first. So I'll take 3 of my cubes and I can kind of think about it. I put it straight, right? That's one combination. And another combination would be this one. Notice there's only 2 combinations that 3 could do. So if I was to sketch that on isometric paper, if I did the straight one here, how I would sketch that is, remember each of these cubes is 0.75, so drawing these on grid paper, each box is 0.25. So I would go up, 3 times 3 is 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9, over 3. Right, so to draw that combination, it would look like this. Right. Now, if I was to look at, say, 4, right, if I did 4 pieces, and notice I want 4 possible combinations for 4 cubes. Now, I'm only going to do one of these with you, but a possible combination could be like an L. So see, I'm just taking some of my cubes and just kind of playing around with it. If I wanted it to be interlocking, I would have to put one up here. Okay, so now I have 4 and it's actually interlocking. It was not interlocking like this because I don't have that extra dimension. They're just flat. Okay, so if I was to draw this, say I draw this combination, notice after I get done with this, you'd put it into your engineering notebook. Now this one looks like I'm drawing each cube separate, but the only reason why I have lines around each one of them is because they are actual edges that you would see. On the one that I drew with just 3, the one right here, notice I did not make each cube separate. All right, whenever you have something, say like this one, you're going to want to go ahead and draw it as one full piece. Don't make them separate. Okay, so this is what this one would look like. And notice I've kind of ran into the other cube, but try not to do that. I'm just trying to kind of save time and do this as quickly as I can. Okay, so this one would look like that. So you're going to find 2 other possible combinations, and you are going to draw those other 2. 5, notice for 5, I can't do this. Because a cube, whenever you're putting it together for your puzzle cube, it's only going to be 3 by 3 by 3. All right, so 5 could maybe be this, or this, or this, so on and so forth. Okay, so you'll need 5 different possible combinations for 5 cubes. And then 6 has 6 different possible combinations. Right? Example, or like this one here is a 6. Right? And again, I would just draw it just like I was with these. And here's another, like a 6. Like 1, 2, 3, 4, 5. Oh, sorry, this one's a 5. This one's not a 6. Okay, but that one from earlier is a 6. So you're going to find 6 different combinations for 6 cubes, 5 for 5 and 4 for 4. All right, and then you're going to label that. Step 2, generate concepts, and you're going to put those in your engineering notebook. Then once you kind of get the hang of it and kind of think, all right, this is what interlocking looks like, this is if it's not, and you kind of get some good ideas, then you're going to draw this here. All right, Mrs. Krumsiek has shown you what her puzzle cube looked like. And so I just kind of want to give you a little bit of how-to on it. All right, so when you create your puzzle cube design, keep in mind that you may only have 5 pieces. Therefore, if you have a piece that has 3 wood cubes, then that means the other 4 pieces are going to have to each be 6. All right, and just do that mathematically. The only other 2 possible combinations is one cube would have 4, which would be the next one having 5, and the rest 6. If you have 3 with 5 cubes in it and 2 with 6. So as you're drawing this, you'll see what I'm talking about, that if you have one piece with 4, you only have 27 cubes. So 27 minus 4, right, is 23. And then the only other possible combinations would be one with 5 and the rest with 6. So realize you only have 27 you're working with, and you have to have 5 pieces. All right. So then you're going to draw it to look like this on your isometric paper. So grab some isometric paper and go ahead and sketch these 3 layers. All right, go ahead and pause it and do that. All right, so what this is representing is the cube. All right, you have 3 layers that's been separated so that you can kind of see what those pieces are going to look like. The best way to do it, don't take your colors now because you may end up messing up. After you have kind of got your numbers on there and you figured out what piece is going to be what, then color it. As you can tell, Mrs. Krumsiek did it that way. All right, so on hers, she has a brown piece. Notice it's got the 3s on it. And that means that this piece is going to the first layer. It looks like a little L. And then it's going to go back. All right, it's kind of like this piece here, right, positioned like this. right? But that piece right there is taken out. Okay? So she's got one piece like that, so it's 1, 2, 3, 4, 5, which means she must be doing either this scenario or this one. Right, so then this top piece is not interlocking. Notice it only goes across the top. There's not a third dimension where it goes down. So 1, 2, 3, 4, 5, 6, and it's not interlocking. Okay, this one here, this yellow one, is also not interlocking. So you want to make sure 4 of yours are interlocking. And the reason why we do that is because if they're interlocking, once you get it together, it's going to stay together. The top and the side aren't going to fall off, kind of thing. All right. So this is kind of a U-shaped. Right? And then she's got one more piece here, the green one, that goes, this is definitely interlocking. So you've got number 2 through here. All right, so let's just kind of play around. I'm not really sure if my first scenario is going to work because sometimes it doesn't. But I'd like to go ahead and do a piece of 3 and then the rest 6, or I could do the 4, 5, 6's combo, or the 5's and the 6 combo. Let's go ahead and do the 3 5's and the 6 combo. So I'm just going to start off by saying, all right, 1s. Make sure you use a pencil because you're probably going to have to erase. So I might just kind of throw some on there. 1, 2, 3, 4, 5. Let's go ahead and get a interlocking on this one. I went this direction, so that makes it interlocking. Right, so now maybe 2. Notice these have to touch because you're going to have to be able to glue them together. 2. Put a 2 here and a 2 here. These are going to line up to where they touch. Okay, so this one touches this one touches this one touches here and here. All right, so 1, 2, 3, 4, 5. And I have a 1, 2, 3, 4, 5, 6. I can do another 5. Let me go ahead and get these in. 3, 3, 3, and 3. So I have 1, 2, 3, 4. I can't go here because it wouldn't be touching. And get an interlocking maybe here. You also have to watch out and make sure you don't draw it like the exact same shape again. So after you color it, you'll kind of be able to tell. If you end up getting any with matching pieces or any that do not have 4 interlocking, you'll know that whenever you do your decision matrix that it doesn't meet those constraints, so it wouldn't get any points for that. So I have 1, 2, 3, 4, 5. So I have 2 things with 5 and 1 with 6. So I'm going to have 1 more with 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. So I'll just do like a 4, a 4, or 4, maybe 4. 1, 2, 3, 4, 5. So I need 1 more with 6. So I've got 1, 2, 3, 4, 5, 6. So this one works out. Whether it's in those constraints or not, I'm not sure yet. Once I color it, I would be able to tell if the shapes are the same or not. I may have some that have matching shapes. If you end up with like the middle one doesn't have anything else touching it and it's left blank, you know you messed up and you need to go ahead and erase some. Okay, so you need to get 3 different possible combinations and make sure that you sketch them colors just like Mrs. Krumzik did here to show what color you're going to actually paint them in the end. Okay, hopefully this helped. I'll do another video for step 3 here later.